clouds outside today, and I'm not talking about the clouds of smoke from guys at school in their trucks.
Hey Jessica, I've seen the clouds of smoke, but not the mother-of-pearl nacreous clouds that I've been learning about in school.
What are these nacreous clouds?
Well, since you asked, they are actually polar stratospheric clouds that form in the stratosphere at high altitudes and extremely low temperatures.
But wait, I thought clouds formed in the troposphere.
Well, Jessica, nacreous clouds requires supercool water, ice crystals, and nitric acid.
Well, come on, let's go find them.
Alrighty.
Where are they at? I don't see any nacreous clouds.
Silly Jessica, they're only found in the Arctic and Antarctica where the temperatures meet negative 85 degrees Celsius. However, due to global warming and ozone destruction, they have been spotted in Canada and Scandinavia.
Well, hey, guess we're moving to Canada.
Why are the clouds so pretty in iridescent colors and pearlescent tones?
Well, as sunlight diffracts through ice crystals, the colors of the clouds are formed. They usually form at sunrise or sunset when the colors stand out against the dark sky.
Since there's different types of clouds in the troposphere, I assume there are different types of nacreous clouds.
Well, look at you. I think you're right, Jocelyn.
There are 3 different types of nacreous clouds, type 1A, 1B, and type 2. Type 1A contains water and nitric acid and consists of large atmospheric particles. 1B contains small spherical particles, sulfuric acid, nitric acid, water, and supercool liquid. Type 2 contains water-rich nitric acid and water.
Do the different types form at different places?
I'm glad you asked, Jessica. Yes, they do. Type 2 clouds rarely form over the Arctic because temperatures do not reach extreme temperatures.
Can you answer this? Which type is more dangerous to the environment?
You betcha. Type 1 are more harmful to environments because they provide sites of stratospheric ozone destruction.
Don't their surfaces act as catalysts to convert man-made chlorine into active radicals like chlorine monoxide?
Yes, Jessica, you're right.
When spring arrives, sunlight destroys the ozone molecules in chain reactions. When the nacreous clouds form, they also remove gaseous nitric acid from the stratosphere that would normally combine with chlorine monoxide to form less reactive forms of chlorine.
I heard that chlorofluorocarbons, CFCs, interact with the nacreous clouds to produce chlorine gas, which kills naturally occurring ozone in the stratosphere, and that the clouds deplete the ozone at a faster rate by supporting these CFC reactions. Is this true? What is the ozone?
Yes, it's true, Jocelyn. I'm glad you asked. Ozone protects us from the sun's harmful radiation. Ozone is produced in the stratosphere by the interaction of ultraviolet radiation with molecular oxygen.
Can you tell me more about CFCs?
Sure thing. CFCs are chemicals containing atoms of carbon, chlorine, and fluorine. They are used in the manufacturing of aerosol sprays and packing materials like refrigerants. A single CFC molecule can destroy 100,000 ozone molecules.
Wow, I didn't know they're sold in the U.S. because they can cause skin cancer, nausea, vomiting, and difficult breathing.
Spot on.
I've heard the ozone hole before. How is this affected by ozone depletion from nacreous clouds and CFCs?
Well, Jocelyn, the ozone forms each year when the total amount of ozone over Antarctica is in decline, which typically occurs during September and October.
That makes sense, since each winter a polar vortex, a low-pressure area near Earth's pole, forms in the stratosphere over the Arctic. With sunlight, temperatures drop to as low as 85 degrees Celsius, where ice clouds form. Here, chlorine and bromine contain compounds and are converted to compounds that catalytically destroy ozone.
You're right, Jocelyn. The destruction of ozone is accelerated by the presence of sunlight in Antarctica in the spring. Fewer clouds form in the Arctic because stratospheric air is warmer due to the lack of land and ocean symmetry. Because few clouds form here, ozone depletion is less in the Arctic.
Is this why ozone destruction in Antarctica is greater than in the Arctic?
Yes, Jocelyn. Scientists have recently discovered that these polar stratospheric clouds are causing ozone depletion to occur at a faster rate in Antarctica at the South Pole than at the North Pole.
I guess this is why the ozone layer over the South Pole is more depleted than the ozone layer in the North Pole.
Yes, Jocelyn. Antarctica experiences more temperatures near negative 85 degrees Celsius, which increases the formation of nacreous clouds, which causes the number of CFC reactions to occur, which increases ozone depletion, which demolishes the ozone layer, which will make all of us die in the near future. Jocelyn, can you tell me why ozone depletion and nacreous clouds are relevant to society? Why should we care about ozone depletion?
Well, Jessica, we should care about ozone depletion because the ozone layer protects us from harmful UV radiation. If these harmful UV rays enter Earth, we have an increased chance of getting non-melanoma skin cancer and cataracts that interfere with vision.
So how does ozone affect wildlife?
Well, the harmful radiation can interfere with nutrient distribution, secondary metabolism, and timing of developmental phases in plants. All of these consequences can reduce vegetation, which can increase carbon dioxide concentration, etc.
I know harmful UV radiation causes damage in early developmental stages of marine wildlife. This can result in reduced populations and alter the pH of water.
So what's your opinion on nacreous clouds, Jessica?
Well, they are beautiful, but if they destroy the ozone layer, it's not worth harming the environment to fulfill our aesthetic desires.
These clouds are being sighted more and more south. There is actually a sighting in Finland, so I think we should make a conscious effort to stop or reduce the use of CFCs for the sake of our planet.